you're here for from SQL to NoSQL, changing your mindset, or a gentle introduction to NoSQL. It is my colon, whatever. But to kick it off, I kind of want to whet your appetite to why this talk's important and why you should be here. And you may not have thought about this, but there's two main bottlenecks for building web applications today. And the first is network speed. So that's the amount of time it takes to get your data from your servers to the client, wherever that is. And the other is database execution speed. So that's on your server, how long it takes your server to get that data, perform those queries, and return it back to the server. We can only control one of these things. For some reason, humans have not been able to break the speed of light barrier that is required to transmit data from a server to a client. We can control how fast our database queries go. Even though they tend to be slow and they always slow down and get slower and slower and slower, but we can control that. We have the technology. So the more you know. Oh, that's a little off. But a little quick introduction. My name is Joe Carlson. I'm a developer advocate at MongoDB and a software engineer. Those are my socials. If you ever want to get a hold of me, Twitter is the best way to do that. This is going to sound ridiculous, but I've been getting really into TikTok recently. I feel like a 30-year-old man playing basketball with a bunch of middle schoolers, but it's a ton of fun. I post a lot of programming stuff on there too, and if you follow me on Twitter, you'll see all my ridiculous videos. Opinions are my own, not my employer. I'm going to say a lot of strong opinions during this talk. It's me, no one else. And lastly, there's a QR code in the corner and links there. I have a post with all of the resources you possibly need, the slides to this, and I'm recording this today too. I'll be posting the video of this talk on that page as well later on today, and my Twitter. Cool. I see phones up, so I'm just going to wait till people are done snapping photos. I will be putting that QR code up several times during the talk. Anytime I have a resource link, I put that back up there again, so if you missed it, there will be more opportunities. Okay, let's see here. I forgot I put that stuff in here, but I stream on Twitch every Friday. Great. Let's jump into this stuff. So, first of all, I just want to say thank you to all y'all for coming. I'm a developer advocate. I get to travel around. I get to work on cool projects, and it's because people like you come to my talks, and I really, really appreciate it. So thank you very much. And who is this for? It's for you, but more specifically too, this is a gentle introduction to NoSQL. So the audience this is kind of intended for is people who've either used SQL or are experts at it or use it even just a little bit, and they're interested in learning NoSQL. Specifically, we're going to be talking about document-based databases, and we're using MongoDB to describe that. Or people who are new to MongoDB and are kind of interested in what's different about it than other offerings in the market today. So I'd like to get a quick poll of where y'all are at. And it helps me kind of gauge where I want to focus and like where we're going to spend time during this talk. But I'm curious if you could put your hands up if you have experience with SQL. Could be, wow, great. Okay, perfect. And I'm curious too, what about MongoDB experience? Great. This is ideal audience. We've got a couple people who've done MongoDB before. No experience required. We have a lot of people who've done SQL. Awesome. This is great. Let me put this up one more time. Get the links there. Well, let's jump in though. So today, what are we going to be talking about? We're going to be mapping concepts that you're familiar with SQL to NoSQL concepts. We'll also be talking about 4 advantages you get with MongoDB or a document-based database that you wouldn't get with an SQL or traditional RDBMS database. And then lastly, we'll talk about 3 key mistakes I see from SQL developers moving into a NoSQL database, and how to avoid those mistakes. Ooh. So firstly, I just want to introduce some key concepts from the ground up. So MongoDB stores data in documents. I think a lot of people, when they think of documents, they think of like a Word document. But MongoDB is a little bit different. They're actually JSON-like documents. We call them BSON for binary instead of JavaScript object notation. But we save those in documents. So think of them as JSON. But they're a little bit, it has more data to it than a traditional JSON document. So first of all, with a document or like an object, you save things in key value pairs. You access data via a key. And those keys are strings. And MongoDB documents can save multiple kinds of document data types, including strings, integers, geolocation data. This is like lat longitude data, arrays, and objects, nested objects as well. Or arrays of objects. You can get as deeply nested as you want on those as well. So the point is, we could save things as JavaScript, but with more verbose data types than you would with traditional JavaScript or traditional JSON. So I think it's key if you're coming from SQL to start with a NoSQL example and kind of show what that looks like in a document-based database. So I want to show modeling a MongoDB document based on a traditional SQL database table that you might be familiar with. So we have our document here on the left, and how would we model the same data in an SQL database? Traditionally, you would start modeling the data in denormalizing it and kind of composing it into different tables, right? Traditional RDBMSs, think of them as Excel spreadsheets, right? You have a bunch of data, columns, rows of data, and you'd be saving that data in that way. So that same data we've highlighted would be saved in its own user table. We may also have a separate professions table that uses foreign keys to link those professions to those users. And lastly, we might have a separate table with additional data on there too that is going to be nested. Cool, nothing too surprising. Let's see here, what did that do? So, yeah, collections of tables. Skip over that for now. Okay, so I want to map some concepts. MongoDB databases differ from a traditional RDBMS by using flexible schema databases. And something you might not have known, I think this is a common misconception of MongoDB, but you can actually enforce schema validation on a database. And actually, I do it quite often. You can do it at a database level. Is anyone familiar with tools like Mongoose? Sit on top of Mongo? No? Okay. You can actually enforce schema validation at a database level on there. So a row of data in an SQL database would be the same as a single document. Ish. All the data, you'd have multiple columns with different attributes. Each of those columns would be a separate field of data within that MongoDB document. MongoDB also has the concept of tables. Databases can have multiple collections per document, just like a traditional SQL database can have multiple tables per document. I said that right? And multiple collections per document, and then tables per document, or tables per database. There we go. Okay, so we have NoSQL databases, or MongoDB specifically, and document-based databases don't have the concept of tables, but we have a related concept. So, time for a terrible joke for you. Stop me if you've heard this one before, but a DBA walks into a NoSQL bar, but leaves immediately because he couldn't find a table. Great. Thank you for laughing. Please clap. MongoDB databases also have a concept of database, similar to a traditional SQL database, multiple tables per database in a MongoDB collection. You have multiple collections per database as well. MongoDB databases, you can also index your tables, or your collections, just like you would with a SQL database as well. And actually use the same B trees that you use to index a traditional SQL database as well. So a lot of these concepts that we've covered so far, it's exactly the same thing. There's just a different name for it and a slightly different way of persisting that data. Okay? We're going to start getting some territory where things actually start to differ more than just the name. For example, in a traditional SQL database, you have the concept of joins. That's where you combine data from multiple denormalized tables, pull them together to produce one single data set. In a MongoDB document, you would embed that data within itself. I will say there is, you can do joins between collections in a document, or between two collections in a MongoDB collections. That is not a problem either. As we'll get into later on in the talk, though, I would consider that an anti-pattern, and we encourage embedding data within it for performance reasons, which we'll be getting to in greater detail in just a moment. But embedding. Embed data instead of doing joins between tables. Also, I think this is another common misconception of MongoDB, that MongoDB does not support ACID transactions. Again, that is false. We actually do support ACID transactions. You can actually do multi-document and multiple transaction level ACID compliant transactions on there too. So you can add a new thing, delete, updates, do a bunch of stuff. You can all make that one persistent ACID transaction, which is amazing. So to recap, we mapped a bunch of terms and concepts from MongoDB. I'm biased because I put this talk together, but this is probably one of my favorite slides. I'll be posting this on that page as well. But a lot of the concepts you're familiar with SQL you can use with a traditional or with MongoDB databases. Cool. And we cover documents and rows, fields and columns, collections versus tables. Databases are still the same. We talked about indexing. We talked about embedding versus doing joins across collections or tables. And we talked about ACID transactions as well. All right, so I don't like to spend a whole lot of time on that. I think it's not too hard to understand. I think the interesting part is understanding key advantages you'd get over a NoSQL document database versus a RDBMS or an SQL database. And these are just 4 of my personal favorite reasons of why a document-based database has advantages over an SQL database. So we'll be talking about how you can program faster, how it's easier to pivot if changes come up in your program. We'll be talking about how querying is much faster. And lastly, we'll be talking about scalability. So let's go through a example of how I have a real-world program example of how it compares to how you program with an SQL database. So let's say you are working on a web app and you have a user form that you need to create. Great. I feel like most of the web is just making fancy forms and we're saving data in fancy ways. So it's pretty common, right? We have our updating our profile, and you have to do some adding, updating, deleting for this new user profile data. Cool. No problem. So we're designing our schemas in both a MongoDB document and with a SQL database. So we have some rows and columns, and we have a document that would save that same data. So what does that look like? We'll be doing this example in Python with both MongoDB and MySQL. So the beginning is pretty similar. Connecting to the MongoDB client is pretty simple. You just point to the address on it to go get it. And same thing with your MySQL database. You just go and get it, tell how to connect where it is, you send the username and password, and go ahead and connect. Not too different yet. Great. But key difference is when we actually start doing the programming on here. So maybe I'll just focus on this one here. So if we want to just go and query and get the user data, with MongoDB, you tell it what database it's in, and then you tell it what you're looking for. So we have our user ID 1 or whatever, and it goes and queries that data. What does that look like? And we only have to get it in one line of code like that because all of our data is embedded within that single document. We just have to get that single document to go get all the data. But if we want to get that same data from MySQL, remember we have it saved in 2 different tables. We have a user table and a professions table. So we have to go and query that data. And because you have this problem of object impedance mismatch, which is the idea that rows and columns don't exist as a native data type in many programming languages. The concept of JSON or objects or key value pairs exists in most major programming languages. So we don't have to do any mapping. We can go get that, and it gets it as an object in memory, or as a dictionary in Python. And with MySQL, we have to map that data from those rows and columns into a native data type that we can use. And then we have to go query that second table to go get that data based on that user, that key. And then save that as a array in our data type that we created in memory. Okay, so that was just querying in an SQL database versus a MongoDB database. What if you wanted to update that user? So what we're doing is we're just creating an object in memory for MongoDB with the data we use. One of the awesome parts about this is how us programmers think, right? We're creating objects of different data types in the native programming languages that we use, right? We use a dictionary from Python to save that data. And we can just save that data as we think about it as programmers in the database. But again, with a SQL database, you have to do that mapping manually. Okay, so all we do is update that one user based on the user ID with the object we saved in memory. But with SQL, we have to go ahead and map that object we created to the MySQL database, and we have to do that for both the user table and the professions table. So to do that, querying and updating, it's 30 lines versus 73 lines of code. Much faster, much easier, and I'd argue easier to understand too. Okay, so we talked about how it can save time programming. I do want to talk about pivoting easier. So one of the key advantages of using a MongoDB database is being able to change the schema of your documents easily. So if you want to add new data or new fields, no problem, you can just add it. As long as it passes your schema validation or whatever, you can add those fields, it's not a problem. Updating data on an SQL database, you have to go ahead and alter those tables and deal with old data. And again, you can do the same thing with a MongoDB database. If you want to make sure every one of those fields or every one of your documents has a field, go ahead, you can update all the old ones, not a problem. But you will have to do that. You have the ability to be as flexible as you want with how strict you want to be with your validation versus having to be strict all the time. I don't know if anyone saw my talk yesterday. I gave a talk on IoT and JS. And I built a IoT kitty litter box, and I was able to add new sensors to my box easily and start tracking that very easily. And I'm using a time series based schema or like schema design. So I didn't really care about the old data. I could just start tracking that new sensor data I'm collecting easily without having to worry about updating the old data, which is out of date anyways. I don't care about the moisture sensor of the box after 90 days or whatever, right? I don't care. So it's, for some use cases, that's super great for moving forward quickly. Okay, as you might know, one of the most expensive parts about developing or querying a SQL database is joining data. And it's expensive in two ways. It's expensive time-wise, but it's also expensive memory-wise, because it has to pull all those tables into memory, and then it does the query on that joined memory. And that can get really expensive if you have a massive amount of concurrent customers hitting that database. But if you're embedding that data within a single document, you don't have to do any joins. That data is there when you need it. This is one of the key things about making a performant NoSQL or MongoDB database, and that's if you have an awesome schema design and you don't have to do crazy queries, all the data you need is within a single document. You don't have to do those joins. You're going to have an insanely fast database query if you can keep all the data you need where you need it. So stop doing it. And again, you can do joins. It's just an anti-pattern. Okay, so who here is familiar with the concept of horizontal versus vertical scaling? Awesome. We got about 50% of the room. If you don't know, I'll cover that really quickly. And I wish I had done this the other way. So let's start with the vertical scaling on the right side here. So if you run out of space with an SQL database, what do you do? What do you do? Well, today, for all RDBMSs, what you do is you go get a bigger hard drive. You have to pause data being sent to the old database, and you have to transfer it all over. So you have some downtime. You have to handle all the stuff in between. It's a huge mess, and it's really expensive. And also, the bigger the databases you get, the more expensive it gets, right? You have this exponential curve of, it starts out pretty cheap, but it gets really, really expensive for those massive hard drives you see on the market today. With the MongoDB databases, you can scale horizontally. So that's on the left here. So what does that mean? If you run out of space on a MongoDB database, you can do something called sharding. It's not sharting. Common misconception. You guys are a tough audience today. That's what usually kills. So horizontal scaling. You shard the database, and what you do is you split up where the data gets sent. You basically have a node that sits on top of all the sharded databases, and it directs your queries sideways. So you can just buy smaller, cheaper databases or hard drives, and you just send data to different ones. And you can just keep scaling out sideways. You don't have to keep stopping migration, moving to a bigger database as you grow and grow and grow. You just keep buying more smaller ones, which as you scale is massively cheaper and easier. There's no downtime, super easy. And it can improve query times too. That's huge too. Like you can do really cool stuff like shard by geolocation. So if I want to put all my Australian users on the shard that's near Australia, they can query that data much faster. The data's going to be super close to them. You can do some really creative ways to start splitting that data up to actually increase performance even more. So horizontal versus vertical scaling, massively important. Okay, so we talked about 4 huge advantages you get with a document-based database over a SQL, legacy SQL database. We talked about programming faster, and we gave the example of querying and updating a user profile page in Python with MongoDB and MySQL. And that was 30 lines of code versus 73 lines of code for that example. We talked about scaling cheaper. We talked about vertical scaling versus horizontal scaling. We talked about querying faster, and we talked about how joins are very slow for databases to perform, and they perform really, really badly at scale. Embedding your data within a document, so you only have to get one document at a time for whatever query you're making, is much, much faster than having to do a bunch of expensive joins. And we talked about pivoting easier, and I talked about my IoT litter box, adding new sensor data and making it really easy to update that schema with that new sensor data I started adding to my box. Okay. Cool. We're going quickly here. This is great. We talked about, and then lastly, we have one more thing. These are 3 of my personal recommendations or personal things I see from SQL developers moving to NoSQL. I think it takes a lot of unlearning to kind of undo your brain. Because I started in PostgreSQL. Awesome. I still love it. Super cool. But whenever I think of data, I think about denormalizing and splitting up the tables, which is super hard. There's a lot of different, and that's hard to unlearn. But I want to talk about some cool things that I discovered since diving really deeply into MongoDB. So let's jump into it. First of all, I want to talk about some MongoDB design patterns. You can get way more creative with MongoDB design patterns than you can with rows and columns. You basically have, how much do I want to split this up into rows and columns? That's basically what you get. You can get really expressive with MongoDB documents, which we'll be jumping into a couple together. I want to talk about fighting the urge to denormalize and keeping that data embedded within each other. We'll give some specific examples of that as well. Whoops. And, ooh, this one's a tough one too. Transactions. I hear transactions, again, you can use them. People get really stuck on how much needs to be a transaction. We're talking about what is the line between what needs to be a transaction and what you can probably let go. So let's start at the beginning. Not all documents in a collection need to have the same fields. So there's a bunch of different expressive design patterns you can use the MongoDB documents. And it's cool. It's like we're still discovering new ways to show this data, but I want to show a couple of my favorites. The first one is a polymorphic pattern. If you're familiar with object-oriented programming, polymorphism basically means you can change the shape of it. Many shapes, right? But I have an example here of our user profile with a bunch of different users with some different data. And I also included my cat on there. His name's Bimo, and you see it's a little tiny document because he doesn't have like a job or a cell phone. So he has a different document shape than me or Paul Miller here, who has many cars. Way to go, Paul. But you can change the shape of it. It's not stuck. I want to show you my favorite pattern, especially for scalability. It kind of blew my mind when I first discovered it, and it's called the outlier pattern. And this is actually a real-world example of how Twitter actually saves their data. So, for example, let's say you are a you want to save your Twitter users one Twitter user per document. Great, no problem. I'm Joe Schmo. I only have a couple thousand followers on Twitter, so maybe I keep an array of my users that follow me embedded in my document. Okay, I only have a couple thousand followers, not a big deal. But what if I get someone like a Kim Kardashian or Justin Bieber on my platform? Embedding millions and millions and millions of followers within that document probably doesn't make sense. And actually, did you know this? If you get a blue check mark on Twitter, that actually means that your data starts getting saved differently in their systems. It starts signaling that your data is scaling up differently, and they start using different schema design patterns to scale that up. And this is a real-world example of what they do. So they use something called the outlier pattern to save those massive outliers like the Biebers and the Kardashians, right? And what they do is they use the polymorphic pattern on there as well. You can see in the bottom here, this may be a little tiny here for the people in the back, but on the bottom it has extras equals true field on there. And what that signifies is that this is an outlier that needs to be handled differently by the code base. And what they do then is they keep X number of followers in there so it doesn't exceed the size of that program. And then they would have overflow documents, sub-documents that have to be queried as well for those complete users. This actually doesn't tend to be a problem because it's actually pretty rare that we need to get all of those followers all at one time anyways. If you're using Twitter anyways, you're paginating that data anyways. You're only getting 10, 20, 50 at a time. You don't need all 50 million in one query. It's not a problem. The key when you're developing your applications is to be thinking about how you're going to be digesting that data. Do I have a dashboard? Maybe I want to have documents that show the results of on my dashboard all at once. I've also done things too where I make separate collections for separate use cases so I can make those queries really quickly. So for example, for my IoT database or IoT project, I have a collection that just gets a real-time write feed of all that data coming from all the boxes out in the field. And I have a separate analytics field that I could use, and I just do all my calculations, save it in different documents, and I display it on a dashboard. But the point is, you can be creative about how you're using that. And yeah, I love the outlier pattern. It's awesome, especially for scalability. I worked for one of the largest e-commerce sites in North America, and we did this too for a lot of our sites too, where scalability and readability was massively important. It was a site too where I'll just say Black Friday was a big deal for us, and we had a lot of major scalability problems we had to deal with. But keep caching the data, all the data we needed, really minimize the stress on Black Friday for making those queries for our databases. Okay, so this one's tricky too, I think, for people, especially who've been in the field for a long time. In the olden days, databases hard drives were really expensive. That's not the case anymore. In fact, the largest cost of database development is actually developers. It's all y'all. It's all of us in this room today. Data is minuscule compared to the cost it costs to employ us, which is where development costs and speed become incredibly important. Most companies don't care about how much money they're spending on databases because it is a fraction of the cost of what it costs to employ us to make that code. So what I see a lot of the time too is people wanting to be really conservative about their data and not repeat data. But even in SQL databases, normalizing or did anyone know the term of normalizing? I should probably go over that again. Normalizing basically means taking multiple tables and combining it into one. And it increases query times because you don't have to do expensive joins. Did I get backwards? Denormalizing? Thank you. I always get those mixed up. Denormalizing means you take multiple tables and you put them into one. The thing though is you're going to be having lots of repeated data if you do that. Okay, not a problem. It's not a problem. Normalizing it's not an anti-pattern for SQL databases, or denormalizing is not an anti-pattern for SQL databases. And it's not for NoSQL databases or MongoDB either. Repeating data is not a problem. You're going to have larger storage costs, but your query times are going to be faster, and it frankly doesn't matter. But I see that a lot with SQL developers coming to NoSQL is they have a hard time with that denormalization and repeating data. Or like, hey, I have to update 6 different documents every single time. Not a problem. It's not a problem. And it isn't with SQL either. It isn't. Okay, and not saying it always is, but it depends on your use case. But yes, this is related to. So if you are, in order to do that too, embedding is also huge too. Try to embed as much as humanly possible. Okay, transactions. This one's a spicy one. I'm not saying ACID transactions are bad. They're not. There's tons of use cases. If I was designing a financial application for a bank, you need to use transactions. I can't have a financial transaction that fails or money gets lost when I'm updating a table. That can't happen, right? And there's lots of use cases where that isn't. I'm just saying we might be over-relying on transactions more than we need. A lot of situations you actually don't need to use them, and I would be pushing back on whether you didn't need to update or not. But yeah, again, transactions are definitely needed, and they're supported in MongoDB, and of course, all RDBMSs or SQL databases on the market today as well. So let's do a quick recap of what we talked about today. So we first talked about mapping key terms and concepts from SQL to MongoDB, documents to rows, whatever, this whole thing here. We talked about 4 advantages, my 4 favorite personal advantages of using MongoDB over an SQL database. We talked about being able to program faster. We gave the example of using Python and MySQL, or MongoDB and MySQL, and we had the 30 lines of code versus 73 lines of code to do the same thing, querying and updating a user profile. We talked about scaling cheaper with document-based databases, specifically MongoDB. I will say this too, if you're looking at other document-based databases on the market today, make sure that they have horizontal scaling. I know a lot of our competitors don't have it. CosmoDB and DocumentDB are actually based on an RDBMS on the back end and actually can't do horizontal scaling. But with MongoDB, you can actually do horizontal scaling, and you don't have to vertically scale. Querying faster. By embedding documents, you don't have to do expensive joins. We talked about pivoting easier, and I gave the example of my IoT litter box, and I was able to update that sensor data on there easily, no problem. And then we talked lastly about 3 key ways to that I see SQL developers getting stuck when they're transitioning to a NoSQL database or doing development work for them. So we talked about how we talked about 2 key design patterns. We talked about the polymorphic pattern, where you can have different shaped documents in a single collection. And we also talked about the outlier pattern, where we talked about how to handle things like Justin Bieber's or the Kim Kardashians on platforms. We talked about how instead of doing joins, you should be embedding your data within a document. And again, that increases query performance of your application. And lastly, we talked about transactions and when you should and should not use them. So I like to end my talks with next steps. MongoDB actually has a course. It's university.mongodb.com. And there's a MongoDB 101 basics course. I'll tell you, this is how I got trained on as an engineer at MongoDB. It's what we use internally to get onboarded, and it's open to the public, and it's amazing. And it's free. You can get certifications on there too, but all the training is free in public, and it's a great way to jump in. We just unveiled this. I'm so happy about this. We have the old way to do it, you have to like download everything in a Vagrant environment. You can actually do all the lessons in the browser, kind of like a Code Academy style or Khan Academy, which I think is awesome. You can do all your database stuff in there too. But M001, MongoDB Basics is a great place to start if you're just jumping in. I would also recommend just trying it out. I get asked a lot about like resources or videos. MongoDB University is awesome because you're getting like hands-on with it. But, and this is just me personally, the best way I learn new technology is just to do it. Other way I do that too is by presenting on it too. It forces me to learn it, but I don't expect everyone to present on new stuff. They're just learning. But if you're working on a project, try it out. It doesn't have to be MongoDB. Do anything, right? Just try out this new database. Play around with it on your own. If you can play around with it at your job, awesome. If not, if you have a side project at home, just try it out in your next project. Personally, I try to do at least one new thing per project. At least one new thing. Maybe I'm going to learn a new framework today, or a new ORM, or a new database, or a new library or something. But I try to do one new thing to continually learn when I'm growing. But anyway, just try. If you want to learn MongoDB or a new NoSQL database, just try it out in your next project. Relatedly, too, if you want to get $200 in free credits, there's a free tier for MongoDB Atlas. It's basically their cloud-hosted option. But if you want $200, I've been using it forever. I've never actually crossed into a paid tier ever. But if you want it just to have it just in case, you can use code JoeCarlson200 to use that QR code. All that stuff's on that site, too, for getting the free $200 or whatever. Just good to keep in your back pocket. You never know. You never know. Let's see here. Actually, I just want to do questions. We got some time here. So anyone have any questions so far?